Okay, now we've got to get familiar with more of the vocabulary. If you notice, find the common difference. The common difference is, translate that into the notation, D. First term is, translated into notation is A sub 1, question mark. 12th term, translated into notation is A sub 12. By the way, we know that n is 12, right? When we're looking for A sub 12. Of the arithmetic sequence, translate that into notation, and you get this. That has A sub 5 equals 1. What does that tell us? What information does that tell us? A sub 5 equals 1. This says that when n equals 5, A sub n equals 1. Correct? You need to know that. You need to read A sub 5 equals 1 as the fifth term is 1, or when n is 5, A sub n is 1. You have to be able to understand it. That is vocabulary. That is the notation. That is likely where you're going to struggle. It's not the math part. It's not the computation part. It's understanding the notation. Okay? If you learn how to do that and you're fluent with that, you're going to be just fine. Email. Same situation is true. A sub 18 being 92 is that the 18th term is 92. Or when n is 18, A sub n is 92. So the question that you're going to get on an assessment will state just the top part. It's not going to scaffold it where it's going to bring it into pieces. So from that, you're just going to need to respond with what to do. Essentially, you can write all this stuff out to set it up, and then you just start mixing all that information together, okay, and trying to calculate some different pieces. For instance, if I know that A sub 5 is 1, and I know that it's an arithmetic sequence, I can put this information right here into the closed form of an arithmetic sequence and find out more information. So that's what we're going to do. Right now, we're going to take this, and we're going to take that. We're going to mix those two together, and then we're going to see what we get. Okay? So that's what I'm going to do right here in the yellow. We're going to do A sub 5 equals, and I did one step in between. That's a little bit of an there just for emphasis. N would be 5. D, we don't know. But we do know what A sub 5 is. So we can write one more step here. You don't have to write that intermediate step that's actually highlighted. You can just go straight to this if you want. Okay, we know that. That's a fact, Jack. Then we also know more information. We know that A sub 18, that's a terrible highlighting, A sub 18 is 92. So we can go back to that same closed form of an arithmetic sequence, and we can put that information in that one and see where that gets us. A sub n being 18, so A sub 18 equals A sub 1 plus n, which was 18, minus 1 times d that we don't know. But we do know what A sub 18 is. A sub 18 is 92, so we get 92 equals A sub 1 plus 17d. By the way, do you notice what just happened? We wrote two equations. How many variables are there? How many variables are there? 2. We have two equations and two variables. That gives us a linear system of two equations and two variables that we know how to solve. We can solve it by graphing. We can solve it by substitution. We can solve it by elimination. Graphing is probably not the easiest one, unless you're fluent with your calculator and you can type it into y equals and then find the intersection point, and that's your answer. But you need to label your x as one of them and your y as the other one. And you need to understand that. Or you can do it algebraically. I prefer to do it using elimination. So I'm going to solve using elimination. By the way, if you did that using your calculator and you're graphing, you write down at the side, solved by graphing on calculator. But first, solve one of these for one of the variables, and then show me what you type in as well. Solve using elimination. If you do that, I would multiply the first equation by just a -1, right? Not too crazy. And we distribute. So we're going to rewrite the system. We get negative 1 equals negative a sub 1 minus 4d. And then we get 92 equals a sub 1 plus 17d. And then we can add those two equations. That becomes 91 equals, that drops out because that equals 0, and we get 13d. And we can solve that and get d equals 7. Great, we did the first part of this question. Woohoo! We're getting it done. Okay, how do we find the other one? How do we find a sub 1? What do we do? Take that value, put it in for d, and solve it for a sub 1. Because we're just solving a system, which is something we are fluent with since Algebra 1. So the math itself shouldn't be a struggle. Doing the calculations and the computations should not be the struggle. The struggle is the notation, hopefully. If solving a system is a struggle for you, you need to let me know so I can help you. So we get 119, and we subtract that from 92. I'm going to do the reverse and then do it by negative 1. So it's negative 27 equals a sub 1. Woohoo! Woot woot. We did it. Not all of it, but we did part of it. We got that one. Now we need the 12th term. We take a deep breath, and we go for the 12th term. So, by the way, if we're still talking about arithmetic sequences, we know this is true. We also know all the parts in there that we need to. We want a sub 12, so we want the 12th term, a sub 12. We know a sub 1, so we write that in there. We know what n is. It's going to be 12. We know what d is. It's going to be 7. Now we can do that calculation, which happens to be what, guys? It happens to be 50. So now we have answered all of our questions, and then we rejoice. Woohoo! We're winners. We did it. Good job. Next setup. Sum of a finite arithmetic sequence. Go. By the way, guys, you know what that n means? That's the term number. You know what that a sub 1 means? That's the first term. You know what that a sub n means? That's the value of the nth term, or what the nth term is. You know what that 2 means? It means 2. Funny. You know what this n means right there? Right there, that last one? That's the term number. S sub n references the sum of the nth term. Sum of the first nth terms. Yes, this. First n terms. Okay, so that's what we're going to do. Now, here's the deal. This is like a different problem. Okay, but what we do know, we know this is an arithmetic sequence. Why do we know that it's an arithmetic sequence besides the fact that we're awesome? We know that it's an arithmetic sequence because each time between terms we add 5, right? What does that automatically tell us about an arithmetic sequence? Translate that into the symbols. D equals 5. Awesome. That's the symbols we need to deal with. We know it's an arithmetic sequence, so we also know, because we're awesome, we also know this. Yeah, that's right. We're awesome, and we know that about arithmetic sequences. So we know what D is. We know what the general form of an arithmetic sequence is. But guess what? We also know more stuff. What else do we know? You know what that gives us? That gives us what a sub 1 is. Woohoo! We're getting closer. Find the sum of the first 20 terms. Oh, we know n is going to be 20. Woohoo! We want to find the sum of the first 20 terms. We know from that statement, we know that this is true. That formula. So we know S sub n equals n times a sub 1 plus a sub n over 2. Woohoo! We know stuff about that we can put in there. Now we know values for those variables, so let's do it. Let's do this. S sub 20 is then going to equal 20 times a sub 1, which is 2, plus, wah, wah. Do we know what a sub 20 is? Do we know what the 20th term is? Wah, wah, no. Can you find the 20th term? Sure, you could keep adding 5, but we're gentlemen. You know, we had a gentleman's agreement that we weren't going to do that, that you were going to use the closed form to figure out what the 20th term is. right? Instead of me writing what some of the first 1 million terms. Okay, so anyways, so we don't know what that is right now. We're just going to leave that. I'm going to erase that and put something in there in a second, okay? So don't write it in pen. All right, we can't solve this because we don't know what a sub n is. So we need to go and find a sub n. Now we got a new problem that we just turned it into. We need to find a sub n. How do we find what a sub n is? We're smart and we know it's an arithmetic sequence, and we know from an arithmetic sequence we have this stuff. So we put the stuff in that closed form equation and we figure out what a sub n is based on that. And that's what we're going to do here. We're going to do a sub 20, which is the thing we want to find out to figure out the sum, is going to equal to a sub 1, which is 2, plus n. Well, we're finding the 20th term, so n is 20. And then we know what d is. Woohoo, it's 5. Calculate that. What does a sub 20 equal then? What? 90, 97. Woohoo! So we write that in as 97. Yes, we're awesome. Sum of the first 20 terms is what? So the sum of the first 20 terms becomes 990. That's exciting. Now, you guys are going to think that question 2 is like a totally separate content or totally separate concept, but it's not. It's just the repackaging of the same exact thing. With the phrase, find the value of a series, I need to define a series for you. A series is a sequence, out of space, sequence that you add. It's an added sequence, which is probably bad English. We'll give you more formal stuff in a little bit. But it's an added sequence. If you notice, these are the terms of the sequence. It goes 4, 8, 12, 16, dot, dot, dot. I didn't want to write it all. And then 200, rather. When we talk about a series, it's adding all the stuff up. But what you need to know about this series, or this sequence that the series represents, is that it's arithmetic. And you can tell that it's arithmetic because 4 to 8, the difference between those is 4. From 8 to 12, difference is 4. From 12 to 16, difference is 4. And that's going to continue. So we know it's arithmetic, and we also know that d equals 4. And because it's a series, we're looking for the first to add up all of these terms all the way till we get to 200 as the value of a sub n. But the problem is we don't know what the term number is at the end. We don't know what term number 200 is. We know what term value 200 is. We don't know what term number is. So if we go ahead and we're adding this all up and finding the sum of it, s sub n, we don't know it. We don't know n, so we just write it in there. But we do know a sub 1, it's 4. Hello. We do know what a sub n is. That's 200. That's nice. We know what 2 is. It's 2. We don't know what n is, so we can't calculate this without first knowing what n is. So in order to find out what n is, guess what we do? We go back to other places that we know. We go back to other stuff that we know. We go back to this equation right here, and we solve it. So we substitute the information we know from this series listed, or this sequence that's represented as a series, into the closed form, and we figure out what the nth term was, what the term value was. So we get 200 equals a sub 1, 4, plus n, we don't know, minus 1, times d, we know as 4. And we solve that, and we get n equal. So we solve this, we get 200 equals 4 plus 4n minus 4. We get 200 equals 4n, and we get n equals 50. So we put 50 into our summation, and we calculate what our sum is. What is our sum? Our sum is 5100 for that problem. But we also have other questions that we need to talk about. To represent a series, we have something called summation notation. From summation notation, it's this big E. By the way, if you're watching TV and somebody's doing math on TV, like the likelihood that there's a summation notation is very high. And then when you see it, you can feel like you're awesome because you studied that. So good for you. Essentially what this